students, welcome in Gokul Global University webcast lecture. In the digital electronics, today we are more discuss about the shift register. In this lecture, we detailed discussion in the introductory part of register, classification of register, serial in serial output shift register, serial in parallel out shift register, parallel in serial out shift register, parallel in parallel out shift register. First of all, what is a register? Flip-flop is a 1-bit memory cell and a group of flip-flop is known as a register. So we can say that the flip-flop are used in a constructing register. Register is a sequential device which can be used for storage of binary information. The n-bit register will consist of n number of flip-flop and it is capable of storing n-bit word. Now one question blink here in your mind, sir, what is word? So we understand the word definition. The series of data bits are stored by register is called byte or a word, where a byte is collection of 8 bit and a word is collection of 60 bits. A register is used to manipulate data for computational purpose by shifting the data in register in either the left or a right direction and therefore is called a shift register. A single bit register is designed using a single D flip-flop. Consider a negative, it's triggered D flip-flop as shown in figure 1.1. It is recalled from the characteristic table of D flip-flop. Then the flip-flop transferred the data applied to the D input to its output at the trailing edge of the clock pulse. Okay, and now n-bit register is set of n flip-flop with a common clock. This n-bit register can store n-bit word. All the flip-flop a given register should respond to the clock pulse simultaneously. Figure 1.2 shown 4-bit register having common clock. Here you see common clock. Okay. All the flip-flops can be cleared by applying 0 to serial terminal. Data inputs are given at DA inputs of the flip-flops. The 4-bit data is transferred to the output at the trailing edge of the clock pulse and the data is determined until other pulse. Now classification of register. The process of information in register is called loading the register. Transferring the information into all the flip-flop of register can be done into two ways. One way is that all the data bits are loaded simultaneously and other ways the bits are loaded bit by bit. Therefore, be classified into serial load shift register and other is parallel load shift register. The stored information in this shift register can be transferred out the register in parallel or in series. So based on this configuration, for combination of loading and reading the data are possible. They are given as a serial in parallel out shift register, serial in serial out shift register, parallel in parallel out shift register, parallel in serial out shift register. Okay, now serial in parallel out shift register. Consider the symmetric diagram of serial in parallel out shown in this figure, and for simplification purpose the flip-flop choose an RD type of flip-flops. They can also be JK type flip-flops. Firstly, the clear signal is applied as a 0 which cleared all the flip-flop given the Q's output 0. So the clock pulse is applied and at the trailing edge of the clock pulse the input on the input data line is transferred to the output of the first flip-flop. So whatever the output of the first flip-flop at that time is transferred to the output of the second flip-flop, and similarly the operation extend to the remaining flip-flop to the right until the last flip-flop. Since the data is loaded to flip-flop serially with each clock pulse, so it is called serial loading of register in serial in. Okay, if the output is sensed at the each one of the flip-flop out, the circuit is termed a parallel out register. So such a register in which data is fed serially to the input and output in is taken in parallel fashion are called serial in parallel out shift register. To understanding the operation of this shift register, consider the data 1111 for 1 is to be loaded serially and 11 to obtain the data at the output in a parallel fashion. So the clear signal first reset all the flip-flop giving Q3, Q2, Q1 and Q0 as a 0. For flip-flop is all are 0. Okay, now the data applied as a 1 to input terminal and at the trailing edge of the first clock pulse data as 1 will be shifted to the right side given the output Q3, Q2, Q1, Q0 as a 1 0 0 0. So here the Q3 is only 1. Okay, similarly at the trailing edge of the second clock pulse output Q3, Q2, Q1, Q0 will be 1 1 and 0 0. So trailing edge of the third and fourth plus output will be 1 1 0 and 1 1 1 1 respectively. So this way the data 1111 is loaded to the register serially and output are obtained simultaneously at Q3, Q2, Q1 and Q0. Here the symmetrically shifting of data is given in the table 1. Here you see the output and input. The logical block diagram of SIPO shift register shown in figure here and the timing diagram shown in this figure 1.5. Okay, now serial in serial out shift register we also called a SISO. A basic 4-bit serial in serial out shift register can be considered using a 4D flip-flop. Shown in the figure here you see the serial output data. The operation of the circuit is as follow. The register is first clearing by applying CLR signal 0 0 0 forcing all for output to 0. Now the output data is then applied sequentially to the input data terminal of the first flip-flop. So during the each clock pulse, one bit transmit from the left to right side. So the data is entered into the register serially during the first 4 clock pulse in the similar manners as has been discussing in a SIPO shift register. To get the data out of the register serially, enter the data must now be shifted serially and taken off at the Q0 output. So for the purpose 4 more clocks are applied and 4 bit required data will be available serially at the Q0 output. Assume the data word 1101 is to be entered serially and taken at the output Q0 byte by byte. So the consider a data 1101 is to be loaded serially and 11 to be obtain this data at the output Q0 byte by byte. Firstly, all the flip-flops are cleared by applying CLR signal. Now, LSB 1 of the data is applied to the input data terminal, and then during the negative edge of the clock pulse the data 1 is shifted to Q3 and giving the output Q3, Q2, Q1, Q0 as a 1 and 000. Here one question also blink in your mind, student. Okay, what is LSB, sir, and what is MSB? LSB means the least significant bit and MSB is the most significant bit. LSB, the least significant bit, is the rightmost bit in a string. It also called the bit. Sorry, it is called that because it has the least effect on the value of the binary number. In the same way as the unit digit in a decimal number has the least effect on the number's value. The LSB also determines whether the given number is odd or even. And MSB in computing the most significant bit, also called the high order bit, is the bit position in the binary number having a greatest value. The MSB is sometimes referred to the high order bit or a leftmost bit due to convention in positional notation of writing more significant digits further to the left. The second LSB 0. So now second LSB 0 of the data is applied to the input terminal, and at the trailing edge of the clock pulse output Q3, Q2, Q1, Q0 will be 0, 1, 0, 0. Similarly, at the trailing edge of the third and fourth clock with the input bits as 1, 1, the output Q3, Q2, Q1 and Q0 will be 1, 0, 1, 0 and 1, 1, 0, 1 respectively. So at the fourth clock pulse, LSB1 is available at the Q2 output. During 5th, 6th and 7th pulse with input data as a 000, the serial output terminal Q0 will be delivered second LSB, third LSB and MSB of the data. All the flip-flop may also cleared by applying one more clock pulse with 0 as the input data. Systematic shifting of the data is illustrated in table 1.2. Here you see the logical block diagram of SISO shift register shown in this figure. Okay. Now parallel in parallel out shift register. More parallel in parallel out shift register, all the data bits appear on the parallel out immediately following the simultaneously enter of the data bit. The 4-bit parallel in parallel out shift register constructed by D flip-flop shown in this figure. The Ds are the parallel inputs and the Qs are the parallel output. Once the parallel transfer signal is high, all the AND gate will be enabled and the data bits get connected to their respective flip-flop. Now, after the application of the clock pulse, all the data at the D inputs appearing at the corresponding Q outputs simultaneously. The logic block diagram of PIPO shift register is shown in this figure. Here you see. Now parallel in serial out shift register. A 4-bit parallel in serial out shift register is shown in this figure. The circuit uses D flip-flop and NAND gates for entering data to the register. D3, D2, D1 and D0 are the parallel input, where D3 is the most significant bit and D0 is the least significant bit. LSB means the write data in the model control line, write or a shift is applied low and the data is clocked in. The data can be shifted when the mode control line is high, as shift is activated high. The register performed a write shift operation on the application of the clock pulse. Here you see in this figure parallel data, write and shift, clock and clear, and serial output. It can be understood in more detail. The data to be entered to the register is applied to the parallel data. Input terminal and mode control line write or a shift is made a low. It allows all the 4 bits of the data were to be entered in parallel into register. In this condition, NAND gates 1 through 5 will be enabled, which allow each data bits to be entered into D input of their respective flip-flop. After the application of clock pulse, the data applied to the input of flip-flop will appear at the output of respective flip-flop. The data is said to be stored in the register. After the data is stored into the register mode, control line write or a shift is made high, and the NAND gate 6 through to 8 will be enabled, which will force the data to be shifted from their present state to next state after the application of clock pulse. Further, shifting is possible with next consecutive pulse. Table 1.3 illustrates the entering of the data, say 1001, into the register and its shifting with clock pulse. The logical block diagram PISO shift register shown in this figure. Here you see the write and shift, low, high, and clock pulse output and serial out, and also logical block diagram of PISO. Okay, I hope you all understand. Okay, thank you.